The first thing you should notice in this question is it says something correct to the nearest millimetre, correct to the nearest millimetre. So it's a bounds question. And in bounds questions you often get a mark just for writing the lower or the upper bound for any of these. So for 8.3 to the nearest millimetre, 8.3 centimetres is the same as 83 millimetres. So if it's correct to the nearest millimetre, your lower bound is going to be 82.5 millimetres and your upper bound is going to be 83.5 millimetres. Remember that your bounds always end in a 5 basically. So in terms of centimetres, it has made it more confusing by saying correct to the nearest millimetre, but I've just converted that to millimetres and turned it into bounds. So in terms of centimetres, my lower bound is going to be 8.25 centimetres and my upper bound is 8.35 centimetres. So similarly, when it talks about side length B, we're using the same logic. The lower bound is 6.05 centimetres and my upper bound is 6.15 centimetres. Calculate the upper bound for C. Now if you know A and B and you're trying to work out what C is, this is a right angle triangle where you know two of the sides and you're trying to work out the third side. They love to mix bounds in with other topics. So here, your first thoughts when you see to the nearest millimetre should be bounds. And your second thought, when you see a right angle triangle, you might be thinking, oh, this might be to do with SOHCAHTOA. Or, once you've realised that you've got two of the side lengths and you're talking about finding the third side length, we're dealing with Pythagoras. So it's these two topics mixed together. So in short, for Pythagoras, we know a squared is equal to b squared plus c squared. But if we're trying to work out what c is, if we get c by itself, c squared is equal to a squared minus b squared. So c is equal to the square root of a squared minus b squared. Okay, now if we want c to be as big as possible, we need a squared minus b squared to be as big as possible. So how do we make a squared minus b squared as big as possible? Well, we use the biggest value we can for a, which is the upper bound, which is 8.35. And because we want to keep this as big as possible, the bit that we subtract, we want to minimize that, so we're going to use the lower bound for b, which is 6.05. Now I always think, if you're not that comfortable with bounds and choosing which one to use, let me just show you the answer before I say this. So it's the square root of 8.35 squared minus 6.05 squared gives you the upper bound, so 5.75. And we're dealing with centimetres. Even though it says to the nearest millimetre, and we use that with our working up here, our measurements are in centimetres. And actually the answer line's quite nice here, it gives you your units. If they don't, and you don't put your units in, you will lose marks, lose pointless marks in your exam. What I was going to say is, if you're not that good at working out which bounds to use in order to maximise to find the upper bound for C, you can try all of them. There's no harm. If you've got time in the exam, try using 8.25 and 6.05, 8.25 and 6.15. Just there's only 4 different combinations you can use with your values for A and your values for B. If you try all of them, you'll see that 5.75, the value that we got here, is the biggest possible option. It's your highest value, your upper bound for C. So if you want to use all different combinations of these and just choose the biggest value, you won't lose marks for that. I've just used logic to work out which ones will give us the biggest value, just to save a little bit of time. If we actually do 18 at the same time, you're expanding double bracket, so I do root A times root A, and then I'm going to do plus root A times minus 2 root B, so that actually becomes negative root A times by minus 2 root B, so it's minus 2 root B times by root A. I've got root 4B times by root A, and then I've got plus root 4b times by minus, so a positive times by a negative is going to make that last one negative, and then a root 4b and a 2 root b. Well, I'm going to put that 2 in front just because it's kind of the norm, it's kind of convention. If we start simplifying, root a times root a is a. It's this root 4b that you've got to be careful with, because root 4b is the same as having 4b to the half, and if you remember, when you've got something like this, you apply the indices to the number and the letter. So root 4b, 4 to the power of a half gives you 2. So it's actually, because when you square root something like this, you can square root the 4 and square root the b separately. It's like saying the square root of ab. There's a rule that's the square root of a times by the square root of b. Like you might say that square root of 18, if you're trying to simplify it, you might break that into root 9, root 2, so that you can then say that is 3 root 2. You might have done something like that before, so breaking it up. So we can say that root 4b is the same as, let me just write this bit in first because it's not, can't really simplify that at the moment. Root 4b is the same as the square root of 4 times by the square root of b. So I'm going to separate that in all of these. So then root 4 is 2. Now straight away I've got minus 2 root b root a and plus 2 root b root a. They're going to cancel out, so I'm just going to put a big cross through them. And this last bit I've got minus 2 times by root 4, which is 2, and root b times root b just gives me b. So that's a minus 2 times 2, so a minus 4b, and that is your final answer. And I'll leave all of the work in shot so that if you want to pause it and have a look through it, obviously you can.